Today now we are going to start the chapter 13, lesson 4, which talking about Newton's law of universal gravitation. This is a fourth of the Newton's make fourth law. Three of them we talk about them first semester, and the fourth one was talking about universal gravitation. Now, the idea, and all of us know that the idea of gravity was introduced by Isaac Newton in the late 1600. He was a scientist who combined ideas to explain how the universe operates. You know, the apple and the apple falling and this story. Let's see it today. How he discovered it. Newton's law of gravitation was discovered while he watched an apple form a tree. The force that pulled the apple to the ground was the same with which apple attract earth. They found that why the apple fall down to the earth, why the apple didn't throw up to the sky, why the apple didn't go out in the straight line. They found that the other force. This force was pulled the apple down to the ground. And the S force didn't affect only the apple or only the book, as an example. No, the gravity pulled all the things on the earth. So, because of gravity, you are being pulled toward your book, your pencil, and every other object around you. So, there's an attractive force affects all things around you. It affects you. It affects your book, your pencil, your calculator, your laptop, everything on the earth is affected or are affected by the earth. So you exert an attractive force on everything around you, and everything around make an exerted force on you. You affect a force, attractive force around everything around you, and everything make an attractive force to you. This attractive force to you, to the other things, or to you, to the earth, we call it gravity. So the attractive force that makes the apple goes down to the earth, or the book when it's fall down on the earth, or you while you are walking, you are going on the earth, you are not flying because of the gravity, which is the attractive force. And the gravitational force depends on two things. Depends on the mass and depends on the distance between the two objects. So the gravitational force depends on two things, mass and distance. Mass of the two masses, as mean like if you have, as I told you now, we have two objects. This is the first one, and this is the second one. Between these two objects now, what did you have? You have an attraction force. Here we have mass 1, and here we have mass 2. Between you and your book, you have an attraction force. You have a gravitational force between them. Now, this force between you and your book depends on two things. Depends on your masses and the distance. This is the distance r between them. The two masses and the distance. And let's see how the gravitational force depends on the mass. They told us that the earth attracts an elephant more than the cat because the elephant has a mass greater than the cat. And the earth attracts the coconut more than the apple because the mass of the coconut is greater than the apple. So this is here the gravitational force depends on the mass. And each planet has a gravitational force different than the other planet or the moon. The Earth has a gravitational force G different than the moon, different than the Mercury, the Mars, or the other planets. Now Newton found that the force, the gravitational force, depends on the two masses and the distance. And as we know in math, that we talk in algebra 2 chapter 8 in the beginning of this semester, I told you that when we have and direct variation between the force and another, or between things and another thing, or between two variables, we must have a constant k. This constant k here, they say that instead of writing this one, we have to write k. Like, did you remember when we said k equals k times x or k of x? Here we have the same. But instead now of writing direct variation, we have to write k. The Newton after some many years, they found that this k is g. Not g small, that's we know at 9.8. No, this g here has a different number. And this g depends on the Earth, depends on the moon, depends on the planet, and so on. It has a different number. And the Earth gravitational force is greater than on the moon. And we know that while we see the astronaut, while they are going on the moon, how they cannot walk as they did while on the Earth. So the gravitational force, this G, is different than from place to place, and it depends on the mass.
Teacher?
Yes.
Teacher, like something I didn't understand. Like, what do you mean about two masses with the distance between them? Like, why? Like, what is the related thing between the gravitational? Yeah, this one. Like, what do you mean about we have like two masses and between them there's a distance? Like the gravitational force is.
Yeah, I mean
they
like
just
between. Yeah, I told you that you have a gravitational force between you and your book, or between you and your laptop. This gravitational force depends on your masses and depends on the distance between you and your laptop.
Oh, okay. Like you mean between my book and me, there's a gravitational force between.
Yes. And between you and the Earth, and between you and something on the Earth here. I told you, Newton said why the apple is going down, because of the gravity. They found that also that there's an attractive force between the apple and the Earth. It is the same as between the Earth and the apple. So this gravitational force between the apple and the Earth depends on the mass of the Earth, the mass of the apple, and the distance between them. And I told you that it depends on the mass and on the distance between them. On the mass, such as the gravitational force of the elephant is more than the gravitational force of the elephant is greater than the cat, because the mass of the elephant is greater. Or as another example, when you gain a weight and you have a 100 weight of mass of 100 kilogram, you found that you have some obstacles to move. But when you lost some weight, you find that you come like butterfly. You can move easily. Why? Because your mass will be less than before, as an example, 2 weeks, because your mass is less than, so you have the force, and since the force depends on the mass, so the gravitational force will be less.
Yes, okay, teacher, thank you.
Yeah. So here, as you see, The gravitational force depends directly proportional with the product of the two masses, mass 1 and mass 2, as I told you. Directly proportional with the two masses. So one of the factors are the two masses. What is the second factor? The distance between them. Let's see now how here that they depend on the distance between the two masses. The gravity between you and the Earth is greater than the gravity between you and the Sun. Why? Because the distance from you to the Earth is less than the distance, less than the distance between you and the Sun. So the gravity depends on the distance. The distance, the gravity between you and the Earth is greater than between you and the Sun, because since the distance increases, the gravitational force decreases. So between, it depends on the distance and on the mass. So it depends now inversely proportional with the square of distance. So the force depends on the two masses, and the force depends or inversely proportional with the distance square. We gather them, we have a force depends on the product of the two masses over distance squared. Now here you have these three masses. The arrows indicate the gravitational force between the objects. Let's see now here. I told you that the gravitational force is small between objects with small masses. Look at here how the width of the arrow. They tell me that the strength, here it has less strength than the second case. So that's mean that since the two masses are small, so the gravitational force will be small. But when I increase the masses now, the gravitational force will be greater or will be larger. So as you see here, the width of the arrows would be greater than the first case. And the third case here, let's take these masses now and make or maximize the distance between them. When we maximize the distance, the gravitational force will be reduced, will be less than the second case. So when we have the maximum gravitational force, when we have the greater, or when we have the maximum masses as we can, with the maximum distance between them. If we want to decrease the gravitational force between two objects, just increase the distance between them. When you increase the distance, the gravitational force will be reduced. By the way, you can measure it in many things in our life. As an example, when you are here and your father, as an example, in your home, living with your home, you find that you have a gravitational, gravitational force between you and him. But when he is living in other country, you find that there's a, okay, you miss him, but there's the force between you and them is very small because of the distance. It just makes sense between them. You find that everything in our life use this gravitational force. So now, see here, all the objects in the universe attract each other through the gravitational force. Everybody attracts the other body only with a force. I attract my laptop with a force. I attract my book with a force. They found that there's a gravitational force. So what is the formula of this gravitational force? As I told you now, the force depends on the two masses and depends on the directly proportional with the two masses and inversely proportional with the distance between them. And then they found that this constant K is G. And this G, it has a value. This value is 6.67 times 10 to the power negative 11. Now be careful. What's the unit? Newton. Meter square over kilogram squared. This is the unit of G. Gravitational constant. This is here. We call it the law of universal gravitation.
But teacher, isn't it Newton times kilogram over meter?
No, let's find how can we find. Let's see here. Where's the? Just a second, please. Okay. Now we say that force G m1 m2 over d squared. So G m square m1 m2 will be f d squared. And how do you find d, or how all the constant, how do they find them? They just say that if we have two masses with a specific distance between them, and we know what is the forces between them, if they found the force, they can find G. They do many experiments in order to find G. As we know, and we find the circumference of the circle. How did they know what is the value of pi? They bring many circles. They have wire as an example. They measure, they bring the wire, they put it around the circle in order to find the circumference of the circle, which is the same as the length of the wire. Then they found that if there is the radius is 2, as an example, or you can say 22 or 7, and they found that the circumference or the length of the wire is 22. So they found that this 22 depends on R. This R is 7. So they say that it means there's a constant here. This constant, let's name it with pi. So they found that if the value of the radius of the circle is 7, so its circumference will be 22. So that's mean pi will be 22 over 7. So the mathematicians or the scientists make more experiments in order to find these constants. Here, as Newton do. They make many experiments in order to find G. Now let's find the unit of G. Here now, so G will be force distance square over m1 times m2. The force is Newton. Distance is meter, and distance square will be meter squared. Mass 1 times mass 2 is mean kilogram squared. So the unit of G will be Newton meter squared over kilogram squared.
Okay, teacher. Thank you.
Yeah. So here, what this is the formula of the gravitation of the law of the universal gravitation. G is 6.67 times 10 negative 11. The unit of the force is in Newton. The mass must be in kilogram, and the distance must be in meter. If it is in centimeter, you have to convert it to be written in meter. Now let's have a mathematical example here. Two students are sitting 1.5 meter apart. So here we have two students. This is the first one, and this is the second one. And the distance between them, 1 meter. One student has a mass of 70 kilograms and the other mass of 52. So now, what is the gravitational force between them? Let's remember that the gravitational force is G, mass 1, mass 2, over G squared. Now, G is 6.67 times 10 to the power negative 11. Mass 1 is 70. Mass 2 is 52. Over 1.5 in meter, yes, squared. So now, let's find the force between them. 70 times 52 over 1.5 squared times 6.67 times 10 to the power negative 11. They found that the force between them is 1.07 times 10 to the power negative 7 in Newton. This is here the force between the two students are sitting 1.5 meter apart. Is it clear?
Yes, teacher.
Yeah.
Now here, the gravitational force between two objects are 2.1 times 10 to the power negative 1 meter. The gravitational force between two objects that they are 2.1 times 10 to the power negative 1 meter apart. So here the distance, we have two objects and the distance between them is 2.1 times 10 to the power negative 1 meter. And they told me now the distance between them 3.2 times 10 to the power negative 6 in Newton. If the mass of the object is 55 kilograms, what is the mass of the second object? Here now, what did we have? We have the force G, M1, M2 over G squared. Now what is the force here? It's 3.2 times 10 to the power negative 6. Now what is G?
It's 33 kilogram.
66.7 times 10 to the power negative 11. Now what is M1? 55. What is M2? Unknown. And what's the distance between them? 2.1 times 10 to the power negative 1 squared.
Teacher, G, isn't it 10?
Why 10?
It is the gravity.
No, miss, I told you this is it's not G small. G small is 10, but G capital 6.67 times 10 to the power negative 11.
Okay.
Let's come back here. This is the value of G.
Yes, okay.
So then, .1 0.21 squared times 3.2 times 10 to the power negative 6 will be 1.41 times 10 to the power negative 7 equals 6.67 times 10 to the power negative 11 times 55 times M2. So M2 will be So M2 will be 38.4 kilogram. So the mass of the second object is 38.4 kilogram. This question, yes. So mass 1 is 55 and mass 2 will be 38.4. Is it clear?
Yes.
Yeah.
Okay. Now, if two objects, each of mass 2.10 to the power 2 kilogram, produce a gravitational force between them of 3.7 times 10 to the power negative 6 Newton, what is the distance between them? So here now what did we have? We have two masses. The two masses is 2 times 10 to the power 2, يعني it's mean 200 kilogram. And the second one, 200 kilogram. They produce a gravitational force between them is equal to 3.7 times 10 to the power negative 6. And they asked me now to find the distance. So the force here, G M1 M2 over D squared. What is the force? It's 3.7 times 10 to the power negative 6. G is 6.67 times 10 to the power negative 11. And since we have the two masses, they are the same, so we can say 200 squared over D squared. So D squared will be 6.67 times 10 to the power negative 11 times 200 squared over 3.7 times 10 to the power negative 6. Then I don't want D squared, I want only D. So D will be square root of 6.67 times 10 to the power negative 11 times 200 squared over 3.7 times 10 to the power negative 6. Is it clear how from where I bring this formula here?
Yeah. Yeah.
So while we find the answer in calculator, we remember that D will be square root, and we can find the derivative of the D. Or if I try to find other formula as G M1 M2 over the force. This is another formula in order to find the distance. Square root of G M1 M2 over the force. Now let's find the distance now. Square root 6.67 times 10 to the power negative 11 times 200 squared over 3.7 times 10 to the power negative 6. Under the square root, we found that D will be 0.849 meter, or we can say the distance is 84.9 centimeter.
Teacher, the distance, isn't it should be like equal meter?
It's a meter, but 0.849 meter. I mean, like it's equal 84.9 centimeter. No, it must be in meter.
Okay.
But if you have, as an example, in the choices, something like this, you have to know how to convert it.
Okay, teacher.
Okay. That's it. Do you have any question?
No, teacher, thank you.
Yeah.
No, teacher. No, teacher. It was interesting. Thank you.
You're welcome. Now, by the way, we finished physics. Okay?
Did
There's
you?
no,
Oh,
yeah. There's no lessons after that. I wrote the cover material.
yeah, I saw it.
So I didn't, there's no lessons will be added. So just that last year, لا, not last year about that one. The you make grade 12, the last year before, okay. They give them chapter 13, lesson 1, 2, 3, and 4.